conversion of energy. So usually, as part of that activity, you lose quite a bit of rice, and some of the rice goes on the floor. The total amount of rice stays the same, but some of it's in your hand, some of it's on the floor. And that's the whole idea with the first and second law. So second law is basically the law of, you can see there, when you change energy from one form to another, some useful energy is always degraded into lower quality energy. In other words, there's a cost. All right, this is a conversion cost. We'll call this cost to convert. All right. The next one is on ionizing radiation. This is radiation with enough energy to free electrons from atoms, forming ions. You can see may cause cancer, gamma, X-rays, and UV. I'm not sure exactly where you might be asked about that. I think that if you connect ionizing radiation with cancer, I think you'd be in pretty good shape there. We had a story that I wanted to share with you. There was a, right near my pastor's daughter, a young daughter, was about 6 to 7 years old, and actually got cancer. She actually had a severe buildup, really a huge tumor, like a huge ball that almost filled her entire chest, her whole thoracic cavity. And everyone's wondering, how could this possibly have happened to a 6 or 7 year old young lady? It's just crazy. But what they theorized was that she used to play underneath some power wires near their house. They had this huge field, and she would play underneath there, right, underneath these wires and so forth. Smiling there, all right. Just a happy little girl playing under the wires, but she did so almost every day. And they theorized that there was some type of maybe radiation, or the passage of electricity actually was a factor in her incurring this cancer. So I can't tell you that they had an exact cause and effect with that, but it's very well thought with it. I am proud to let you know that she's doing quite well now. She's married. She's in her 30s, married, living in the South, and as a mom and all that. So she's doing quite well. But anyway, I would think of ionizing radiation with cancer. High and low quality energy basically kind of ties in with these two, the first and second laws of thermodynamics that we talked about earlier. High quality energy would be like coal. All right, this is basically oil. It could be natural gas. All right, it's basically, I'll call it concentrated or densely packed energy. All right, and then the low quality, that would be high quality energy. All right, and then energy would be that disorganized, very dilute energy, if you will. All right, that would be in effect heat that's lost during a process of energy conversion, i.e. the rice dropped on the floor during relay rice and so forth. Solar, this is a big thing with solar, in that the solar radiation is basically not very compact energy, and most of solar technology, most of the work in terms of been trying to improve solar, is really about trying to concentrate it. I'll just put concentration efforts. All right, as we go through this with it. I'm going to do a couple more, and then that will be it for this particular video. I appreciate hope you're getting something out of this as we talk. So that was high and low quality energy. Natural radioactive decay is when you have basically some heavier atoms that are unstable. They can release gamma rays and alpha and beta particles. Radon is a good example of that. And again, you tie in this with, there's a nice tie-in here with, or not such a nice tie-in, but a important tie-in with cancer. All right, radon, if you remember, we talked video with that with radon in the basements of homes. When you sell a home, you've got to get it checked for radon to make sure about that. So I'm just going to put a note here. These are basically, if it's natural radio, these are heavier atoms. All right. Just think of a heavier, clunkier, if you will. And when they break down, they can release some of these gamma rays. All right. A half-life is the time that it takes for half the mass of a radioisotope to decay. A radioactive isotope must be stored for approximately 10 half-lives until it decays to a safe level. So basically, you would 10 half-lives. You would go from 1/2. All right. The next one you'd have 1/4 of it left. The next one you would have 1/8 of it left, and so forth. For that to make sure before it's safe. Nuclear fission and fusion, I'll kind of cover together. Fission is the process now. This is current technology in nuclear power. All right, so basically in nuclear fission, this is characterized by the nuclei of isotopes splitting apart, most notably uranium. All right, and when they are struck by neutrons. In other words, you start this reaction, and then basically the reaction, there's like a chain reaction that takes place. In effect, this is a splitting apart, and there's tremendous amounts of heat released. All right, the heat is released. Nuclear fusion is just the opposite. This is basically forcing a couple of atoms together, and this is what's theorized takes place on the sun. So you can have two hydrogen atoms being fused together. Each one of these has an atomic number of 1, which basically means there's 1 proton in the nucleus, and they form a helium atom. That's why we talk about like heliocentric refers to the sun and so forth. You can see they're forced together at high temperatures till they fuse to form a heavier nucleus. Happens in the sun, very difficult to accomplish on Earth, mostly because we don't have the equipment. We don't have the equipment to really do this. The heat and the pressure. The heat and the pressure is so high at this point that we don't have the equipment necessary to handle that type of heat. The heat that will be generated and the pressure that's needed to get that to fuse the two together. But in the not too distant future, we could. Well, I shouldn't say that. It's a possibility. It's certainly being researched. I don't know if I'll see that in my lifetime or yours, but this is a pretty exciting possibility. But these are just opposites. So this is. Remember, nuclear fission is well established. This is the one we use for current nuclear technology to run nuclear power plants, nuclear subs for the Navy, and so forth. The nuclear fusion is the hope. So this is current now. All right, and this one may be in the future. All right, and I think I'm going to conclude there for our first DVD on this. I hope this is helpful to you. I trust you would watch it, and we can gather some information on that. Just as one last thing I want you to be thinking about as we do this. Remember the connections. So we always want to think about the connections in this course. The air, you want to figure out the connections with the air and the dirt, all right, and the water. All right, so you've always got to think about how all of these are interconnected. how does what's happening in the air, for example, affect the water? How does what's happening with the water affect what's going on in the air, and so forth? And then someplace in the middle here, you always want to think about energy, all right? So energy is sort of transcendent for all that. So always think of your triangle, kind of energy sort of in the middle there, to think of the big picture with that. Thank you very, very much.